Hey guys, I hope that y'all did really well on your Unit 1 test. We're going to do some pretty neat activities with regression whenever I get back on Monday. But for right now, we are just going to kind of start with the basics. Some of the stuff you've definitely done before, so it may be a review. I'm going to go through it fairly quickly. If you're having trouble, you can read over the notes. I'm definitely not going to read them to you. All right, so Unit 2 is going to basically, we're going to split it into two parts. The first part is going to be a linear regression, which you actually probably should have done in Algebra 2. I'm not quite sure if all of you did it in Algebra 2. The other part that we're going to talk about is probability. And so we'll probably split it up kind of like we did before, where we have the first part of regression, then we have a quiz, and then we'll have the second part of probability, and then we'll throw it all together and have a big test. So the first thing we're going to start with linear regression is we're going to talk about taking x and y variables. These two variables, the x part is called your explanatory variable. It's that part right there, except this is not writing for me. Weird. It's called, oh, there we go. It's a little slow today, I guess. It's called the explanatory variable. And so what's going to happen is as the explanatory variable changes, it's going to affect the response variable. So if we look down here at this graph on backpacks, we're going to talk about this graph some more in just a second, but I want to talk about the x and y variables. So the body weight that you have, this right here, is going to determine what pack weight you carry. So your x variable always is going to determine what your y variable is. Now this actually wouldn't make sense if you flipped it around and switched the axes, because your pack weight isn't going to determine your body weight. You know, I wish that I could put on a magic pack and it would make me 40 pounds lighter, but I don't think that it's going to do that. So your pack weight is not going to change or affect your body weight. Your body weight is going to affect the pack weight that you carry. So you have to make sure that you pay attention as to, okay, when this one changes, how does it affect that one? Or if this one changes, will it change the other one? And this is going to be kind of how you decide what goes on your x or y axes. Sometimes it's not going to matter, and you're going to get a relationship either way. All right, so those are your response and explanatory variables. So now we're going to talk about making a scatter plot. We generally, you may have to do one by hand one time on your homework and possibly one time on a test. But I think it's fairly simple. I'm not going to explain it to you. The only thing I would like to talk about is how you label your axes, because this is where most students lose points on exams. So whenever you draw a scatter plot, what you're going to do is you're going to look at your x variables. You're going to see where your smallest x variable is, what that value, and the value of your largest x variable. Then you're going to look at the smallest value for y and the largest value. And this is how you're going to set the scale. You always have to make sure, just like they did here, that you have equal distance between all of your points. Like that right there. They counted up by tens. You can't just go through and label your x-axis with the values that you're given, because generally they're not going to be to scale. And I want an equal distance between each one of those tick marks on your x-axis. The only way to get an equal distance is to put equal values between each one. You know, here we have 10 between each one. Here they've counted by twos on the y-axis. And the smallest pack weight was, let's see, 24, I believe, if I look at that correctly. So they picked 20. I like to use nice round numbers, you know, tens or twos or whatever. It really is up to you, as long as you're putting equal distance, labeling correctly, and everything is nice and neat. Now, one other thing I want you to look at is the fact that they have labeled in words what the x and the y axes mean. Here we have body weight. That's what the X is. Here we have pack weight, and we've listed the units. This is going to be something that I'm looking for on all of your graphs also. So make sure that you put nice, neat, even tick marks on your X and Y axes, and then you also put, you label what they actually are in their units. Now notice that you don't actually have to start at 0. Here they started at 100 for body weight and 20 for pack weight. You just have to make sure that you label correctly. You can skip at the beginning, and where you start, that can be the beginning of your x-axis. But you cannot skip in between, which is something I think I got on to y'all about on your quiz when I was grading them about your stem and leaf plots, how you can't skip stems. You can't skip if you're making a dot plot in between. You can't also skip in between here. We want to see if there's big gaps and you don't have data values. That's important to us. We just don't care about what happens between 0 and your first point. So that's why we can start later than 0. Okay, so I want to talk to y'all, instead of us doing one by hand, because that's really boring, and y'all know how to do that, we're going to do one on the calculator. Because a lot of times you're just interested in kind of the overall shape and all these things, and we just need to visually look at the graph. We don't actually need to draw it out. And the easiest way to do that if you're given a set of data is to graph it on your calculator. So what I'd like for y'all to do right now is I'd like for you to get out your calculators. If you haven't gotten one, please go get one when I pause the video, or when you pause the video actually, and put the body weight in L1. Your X values are always going to go in L1, and put the pack weight in L2. That's going to be your Y. So for us, X is going to be L1, Y is going to be L2. And then put those in your L1 and L2, pause the video, do that, and then come back, and we'll look at the graph. Okay, so I have lots of things actually, but in my L1 and L2 I have this data. Here we go. And so what I want to do is I want to graph a scatter plot. And now I don't think we've done graphs on here. Have I showed you yet? I don't remember. So I'm going to show you how to do this. So you probably want to pay pretty close attention. Are y'all with me? I hope so. Okay, so we have this thing up here above the y equals. You see the y equals here. I don't know if I can make my cursor go. Yeah. That says stat plot. So we want to press second y equals. And this is how we're going to plot statistics. Stat obviously stands for statistics. We have lots of different graphs we can make. We can actually make histograms and box plots and all of those things that we did in Unit 1. I didn't show you how because I thought it'd be too complicated on the videos. We didn't do that. But I do want to show you how to make a scatter plot. Alright, so once you have your data in L1 and L2, what you're going to do, you press second y equals. You're going to hit enter on plot 1. And then you're going to hit enter on. That's kind of redundant, but we're going to do that. We're going to hit enter on. And then we're going to come down and we're going to select the scatter plot, which is this very first one that the cursor is flashing on. If you'll notice, there are other types of graphs. The bar graph on the top right is a histogram. We have a modified box plot on the bottom left, and then a normal box plot. And the other two we don't use very often. The one on the bottom right I think is an ogive, but anyway. Alright, so then we want to tell it where is our X list and where is our Y list. Our X list is in L1, so that's what it says. If yours says something else, change it to L1. You can do that by pressing second 1. Our Y list is in L2. If yours says something else, press second 2. Alright, so now we have our plot turned on. We have selected scatter plot, and we've told it what X list and Y list. Now we're going to actually graph. So we're going to press zoom. And then we have a cheater's way to graph. We'll work on the rest of it later. This is the cheater's way. And if we go down to zoom 9, that's zoom stat. And it'll take whatever plot you have you're trying to plot, and it'll fix the window so it looks nice. And we're going to hit enter on zoom 9. And here is our scatter plot. And if we take this, take a look at that. Let's see if I did a fairly good job. It looks pretty close to what we have here. I think the window is a little different, so it's not going to look exactly like it, but fairly close. Alright, so We want to talk, a lot of times you're asked to interpret scatter plots, kind of like you were asked to describe distributions, you had to cuss. So here we have three things that we want to talk about when we interpret, a scatter plot. And this is on the next page of your notes, so let's take a look at that. We have three things. We have what is called direction, form, and strength. Okay, so direction is going to be, we have direction right here. Direction is going to be positive or negative. If your graph is as x increases, if y increases, just like we have right here, as x goes up, y increases. That means positive direction. Also, if you were to draw a line through it and the slope were positive, this would also be positive direction. All right, now as x increases, if y decreases, that's negative direction. So direction is either going to be positive or negative. Sometimes we'll call this association also. The form is going to be either curved or straight. And it's generally the only form that you'll see for what we're doing. So direction is positive or negative. Form is going to be curved or straight. And we like to use that word slightly or approximately. Here, this isn't perfectly straight. If I were to look at this, I would see that there might be a little bit of a curve in it. But if we look at the other graph, I would say that this is fairly straight because although we have this point down there, we have this point up there, and if we were to draw a line, it would kind of go straight right through the middle. Now, if we lost one of these 2 points, I might call it slightly curved. Okay, and then the last one is going to be strength. And this is going to be, I guess it's kind of hard to describe, but it's going to be how much your data fits the form. So if your data has a really nice curve to it like this, see how I drew that out? Forget this other little mark right here. I don't know why that's there. There we go. Then we would say that has a strong curved form. If your data, say it does something like this. I hope you can see these little dots that I'm drawing over here on the left-hand side. Then we would say this has a strong linear form. See how those form a very nice straight line. Now on both of these, I would say that probably both of this graph and the one we looked at, I would call moderate or moderately strong. You can tell they have a definite pattern, but it's not perfectly fit to either the curve or the line. We have a value called correlation. R is what it stands for. You've probably dealt with R in maybe your science fair projects. This really shows the strength of a relationship in a number, so it's a lot easier to tell how strong it is. But as of right now, we're just kind of guessing. So I would probably say, what do they say here? It says how closely the points follow a clear form, and they say it's moderately strong. And that's probably what I would call it also. I would also call the other graph that we did on the previous page moderately strong, because it definitely follows a pretty straight line. It's not perfect. One that wouldn't be moderately strong, one that would be weak, would be one that's kind of... I lost the mic. Would be one that's all over the place. So it would look like this. I would say that probably goes in somewhat of a positive direction, but it has a fairly weak form because it doesn't really follow a nice pattern. All right. It's kind of guesswork, which is what we do sometimes in statistics. I know y'all love it. All right, so positive association and negative association is the same thing as direction. If x increases, as x increases, y increases, you have positive association. As x increases, y decreases, you have negative association. This right here would be negative. Okay, so here's an example on interpreting a scatter plot. So what I would say here is I would say, and I'm not going to write a whole bunch of sentences like they do, I'm just going to make a list. So we have direction, just like this, like bullets, and I'm going to say positive. The form is fairly straight. And then the strength is moderately strong. Let's see how close I got. They probably said a whole bunch more crap with saying the same thing. So it appears that, okay, so we say there's a positive association. It's somewhat linear, so we could say linear, right? That stands for straight line. And then moderately strong. That's pretty much all I'm looking for. You don't have to go into all this other detail. Okay, so what I want y'all to do, I've already shown you how to, if we look over on the next page, I've already shown you how to do a scatter plot on the calculators. They kind of give you some instructions here in case you need them later. So we're going to do this practice problem number 10. So what I want y'all to do, I want you to take this data, put it in your calculator, make a scatter plot on your calculator, and then describe the form strength and direction of the relationship. Pause the video, work with the partner and do this, and then come back and I'll show you the solution. All right, here is the solution. You see I've taken, and I did that fancy trick where I copied the calculator screen over here. So I plotted the data. I went in and if you, on your calculator, since you just had that plot on, then you really shouldn't have had to do anything under stat plot. You should have just had to change the window. So what you should have done to do this on your calculator is to put the mass in L1 and the rate in L2. And then go through and once you do that, your stat plot should already be on from the previous example, so then you just needed to do zoom 9 and get your window. And then here is my interpretation of the scatter plot. It's fairly straightforward. All right, so the next thing I want to look at is I want to look at what's called correlation. This is on your next page. Oh, oops, I gotta go back the other way. So correlation is a number that we can calculate that has this really nasty, disgusting formula that we will never use. The calculator can calculate correlation for us, or generally it's just given to us and we're asked to interpret it. So once again, AP Stat is not really about calculating things, it's more about understanding and interpreting things. So this is pretty much what we're going to be doing with correlation. There was some things I wanted to point out to you. Correlation is always going to be between -1 and +1. This says this right here. It's pretty simple. Correlation indicates how strong a linear relationship is. The closer you are, if I can spell that, to 1 or -1, the stronger the linear relationship is. Correlation won't tell you about any other kind of relationship. It will just tell you about the linear relationship. I kind of ran out of room there. It will just tell you about linear. Now, it also tells you about the direction. And this is so simple, I don't want to write it down. If r is greater than 0, you have a positive association. If r is less than 0, you have a negative association. So that's fairly straightforward. Here is kind of a little guide. We talk about the strength of your linear relationship. This is pretty much what I do. I wish I would have typed this out, but I didn't. So let's take a look at this. Oh, wow. Look what she did. She put a web page on here. How fun. So sorry. So when we talk about the strength of the relationship, there are pretty much 3 things that I think about. I think about a weak relationship, a moderate relationship, moderately strong, And then just simply strong. Maybe y'all feel this way about your own relationships. I don't know. I don't really care, honestly, about your own relationships. Okay, so for a weak relationship, what I told you, let's think back, about correlation is that the closer it is to +1 or -1, the stronger the relationship is. So the closer it is to 0, the weaker the relationship. So if R is between 0 and 0.3, and this also, all of these are going to work for both positive and negative values. So also between -0.3 and we have a weak relationship. A moderate relationship is going to be between 0.3 and 0.7. And then also the same way with negative. -0.3, whatever. Moderately strong, I would say, is between 0.7 and 0.9. And then strong is going to be between 0.9 and 1. It can actually equal 1. And if you ever have one that exactly equals one of these, then just, I don't know, figure it out on your own. R is such a nasty formula, I can't ever imagine how you would get a value that was exactly 0.9. Now, I could see how you could get exactly 1 or exactly -1. If you have a perfect linear relationship, if you plug the points like 1, 1, 2, 2, 3, 3, 4, 4, and then calculated R, you'd have a perfect linear relationship, and R would be 1. All right, so this tells you about the strength of your correlation. Now, we do have one thing that happens to correlation. We kind of talked about this word outlier in the last lesson. Well, we're going to talk about it again. Outliers decrease your correlation. And they like to ask questions like this. If we removed this outlier, what would happen to the correlation? Well, if an outlier in your data set decreases the correlation, if you were to remove it, it would increase the correlation. And we're going to look at a question like that in just a second. So say we had this data set right here, and we threw this extra number in it. This number over here. Now this, we have a fairly nice, fairly strong linear relationship here. But when we have this outlier, what's going to happen when we calculate correlation, correlation is not resistant to outliers. Just like mean, standard deviation, all that stuff is not resistant. So it's going to cause it to decrease, cause the correlation to decrease. And it doesn't matter where the outlier is. The outlier could be over here on the negative side. It could be up here on the positive side. It doesn't matter where it is. It's just going to cause it not to have as strong of a linear relationship, which would cause it to decrease. All right, so here is this disgustingly nasty formula for R that we won't use. So we put it there so you could see how disgusting it is, and then we're going to make it go away. All right, so here what they've done is they've taken this data about body weight and pack weight, and they have calculated R. They've told you it's 0.795, and they've asked you to interpret R in context. So what you're going to do if you want to interpret R, you're going to tell the direction and strength, and you're going to give context. So what they say, if I were going to interpret this without looking at the answer, I would say that a correlation of 0.795 has a moderately strong and positive in direction, and represents the relationship between body weight and pack weight. I think they probably said it better than I would, but you can also read their answer. All right, so, and then they asked if we removed this outlier here, what would happen? Well, we would have a much stronger linear relationship, and so R would increase. Okay, so this is kind of interesting. So read that little thing at the bottom. Sometimes you'll have a nice curved pattern. It may just have a slight curve to it, and then when you calculate R, it ends up being fairly close to 1. So always make sure that you graph things before you claim that it has a strong linear relationship. You always want to look at the graph. Don't just use what R is. So what I want you to do is I want you to answer questions 22 and with your partner and pause the video, and then we'll come back and talk about the answer. All right, so here's what I got. I interpreted the relationship. I said that we have a correlation of 0.87, so this shows a moderately strong positive relationship. You know it's positive because the correlation is positive. Also because by looking at the graph, you can see that as x increases, y increases. And I used context, right? They're talking about brain weight versus or body weight versus brain weight. So I used context. And then same question that you had before. Removing the outlier will cause the correlation to increase or move closer to 1. All right, so just have a few more things to tell you about correlation. If we go back to the very last page in your notes, there's a few things I wanted to point out. I like this little one right here. That's cute. Okay, so let's see, what did I say? What notes did I make? Is switching the x and the y will not change your correlation. So it's kind of interesting. Your units don't affect R. So one of the things, I think a question they like to ask is, you know, we have this data measured in inches. If we switch it to feet, how will the correlation change? You know, will we divide by 12, multiply by 12, whatever we do, the correlation will stay the same. Correlation is unitless. So the units will cancel, and so no matter what, your correlation will stay the same no matter what units you're in. Let's see what else I think was cool. Correlation, I kind of told you, only describes linear relationships, and it's not resistant to outliers. So we talked about that before. All right, so that's pretty much all I have for you today. I think my video was not too long for you. I'll be back on Monday. So I'll need one more video, and then you'll see me soon. And your homework for Unit 2, Day 1 is going to be due next class, so make sure that you get that turned in. We will discuss your tests and all of those things when I get back, so don't worry about it now. I'll have everything for you on Monday. All right, we'll talk to y'all later.